Good morning. We are here at Automate Live, day 2 of the 2024 Automate Conference, and we are joined by 3 astute individuals from Kistler. We have Hiro Natsume, we have Jim Vaughn, and we have Petr Starustka. Welcome to the show, gentlemen.
Thank you.
Thank you.
Thank you for inviting.
So we have a plethora of topics to cover today, but first and foremost, we want to start off getting to know Kistler. So, Petr, I'd say the first question would go to you. So, we talked about it outside of the booth. When you're describing Kistler to someone for the first time, maybe you're having a beverage with them, maybe you're at the booth here at Automate, how do you describe it to them in simple terms? Tell us about what you do.
I would say simply, where I started on my Kistler is a Swiss company. It says quite a lot. It's a family-owned company, and the owner is working with us. So he managed the company, and it's very easy and simple to work if you are in the direct contact with your owner. From the professional point of view, I would say Kistler is focusing for measurement technology. I would say we are leaders in the dynamic measurement. We are talking mainly here for the pressure, forces, torque and acceleration, and we apply it in the different industries. We are focusing for R&D, mainly in automotive industry. I would say in last years we are quite good also in aerospace and defense. Then we have a small, but in US, quite significant industry for us, infrastructure, and we do so-called weight in motion. We weight here the trucks on your highways and if necessary penalize them. And we add very interesting application to that. It's a bridge monitoring. We are trying to monitor bridges to protect and predict the safety of that. And the big one, and go to the Automate here, is industry, of course. And here we are historically in automotive, and we will still be the biggest in automotive. But in the last 6 years is significantly growing for us, medical technique and semicon industry, as well as standard electric and 3C. If I go back to the company, for Swiss, it's a mid-sized company. I don't know, for US, we are 2,200 people. But we are located in about 60 facilities around the world, more or less following historically the automotive industry. If you look for our logo, in the Kistler logo is written measure, analyze and innovate. And this says what we are doing, very simply. We are focusing for the right, much precise and best measurement, and that's how you can see what's going on. So we think that we help our customer to see through the measurement and application what's going on in his processes. That's basic. In industry, all this is focused more or less for the quality checking in industry, and we have application that you have a zero defect in production. I would say briefly, if we would have more time, we can continue another 2 hours.
Yeah. No, that's you're doing a lot. You talked about dynamic measurement. I love what you mentioned about an application in bridge monitoring, not to mention your growth, automotive, growing into the semiconductor space. There's a lot going on at Kistler right now. And actually, as you were ending there, I was reading the logo. You measure, analyze, and innovate, which is exactly where we're going to go with our conversation next, because I want to talk about the importance of data and analysis as it relates to innovation. So, Petr, this is another question for you. Can you share an example of how you've helped a customer gain new insight by leveraging data?
So more you measure, you get more and more data. It's a question if you really get more informations. So you try to transfer the data to some kind of information, and it is not a general, it is really connected with application. Maybe example from industry. If we are looking for the quality checking in industry, you have a production line, you produce and we measure, let's say, joining process, forces, and for each piece we measure that it's correctly done.
Excellent.
Customer also innovate. They try to change the process, they try to speed it up. So we had an example when customers speeded up the process to get more, and from quality point of view it was quite good. In some moment we started to measure something that was not normal. And we did not understand it. So we used the data from other sensors, and we found that when customer increase the speed, the production line has a small vibration, which is not visible, but influence measuring, for instance. Yeah. So we really made a data analysis and found it, and we were able to compensate it. So this was working. By that, we found that with this application, we opened completely new application, and we were able to say to customer what is going on with the line. If the line is vibrate only because of the speed, or because something is wrong. And we found that, and we bring him the, let's say, predictive maintenance application. What I want to say here is that if you have more data and somebody start to analyze it, many people came with the new idea, and you are able to realize it. It was not so easy and automatic in the past because this data were relatively isolated. When you have it in the package, you can do a lot of things. Oh, this was, let's say, example.
I think it's there where the data quality becomes then critical. So these days with Industry 4.0, there's so much data available, but it really comes then down to the quality of that data. You need transparency, but in the process, but to get that transparency, you have to ensure that you have reliable, accurate data in order to make those assessments.
I like where this is going because ensuring that data is reliable is critical, right? We're talking about data quality here, which I think this will be a question for you. How do you guarantee measurement access in this case? If it's so critical, if it's so important, how are we guaranteeing that accuracy, so that way you are able to find when you speed up a line that there is a mini vibration there that's causing issues?
So in many cases, we utilize the piezo sensor technology for force sensing, torque sensing, pressure sensing, and the piezo sensor offers quite good advantages on mass production environment, and it is highly repeatable, extremely high rigidity. So those and compact and lightweight, those are the the advantages the sensor itself offers, so that the accuracy and the repeatability of the measurement is guaranteed on assembly line. That may be one of the examples that I can provide.
Great example. Jim, do you have anything you wanted to add to that one?
I think once you've got the data, is what do you do with the data afterwards? So in different industries, we have also then different ways of taking that data, that transparency in the data, and then having the ability to analyze that data and use it for quality assurance purposes, also for statistical analysis. So it's start with the data initially and then take it into the data management and use that then to control your processes. So that leads then, especially in areas like plastics injection molding, we have full solutions available, which goes right through from the mold manufacturers through to the contract manufacturers, and then finally maybe to the end user, which may be the pharmaceutical company, for example. Each one has their own need for that data, and how they want to analyze that data and use it will be in a slightly different way. One is looking at it from the pharmaceutical companies want to ensure whichever contract manufacturer they're using, they're getting the quality assurance they need, and that 100% quality assurance in the production line. The mold maker may have other applications for using that data, and the same for the contract manufacturer. So it's giving them the information they need, that transparency to take that data and use it how they need it. But first, fundamentally, as Hiro was saying, you have to have reliable, high quality data. Otherwise, you'll come to an incorrect decision on your analysis.
So we've covered a lot of ground around data, applications, industry, quality, reliability. There's one topic we haven't totally touched on yet, and that's sustainability. Hiro, one other question for you. Can you tell us about the energy and efficiency benefits of electromechanical joining systems? Because every company impacts sustainability in some way,
Sure.
and I feel this is the way that Kistler really has that impact.
Yeah. So electromechanical joining system is often compared with a pneumatic actuator or the hydraulic actuators. And those different technologies can offer different advantages or disadvantages. And one of them is the sustainability and the energy consumption. There's actually a white paper coming out from Kistler Instrument soon, but the study from the university in Germany proved that the energy consumption on a hydraulic system is 6 times more for similar applications for joining type applications. And also the pneumatic systems is the energy consumption with the pneumatic system is 9 times more. So from that, you can say the electromechanical joining system will have significant advantage in energy consumption. And for coming back to the sustainability discussion, by having less energy consumption, obviously you can connect to less CO2 emission, and also different side of the technology, electromechanical joining system, is that compared to pneumatic system or the hydraulic systems, we can have significantly better control on the process. By having better process, typically you have less waste, less defective product being produced from the assembly lines. So that is also a sustainability discussion. If you have less waste, then less material discarded, and that is also a big advantage. And also having the pneumatic system or the hydraulic system comparison to that electromechanical joining system typically have significantly less cost of ownership, maintenance requirement, things like that. And all that less requirement will connect to the sustainability discussions.
Really strong answer as, let's say, the one of the final questions in the interview. 6 times more energy for hydraulic systems, 9 times for pneumatics. So there's an immediate benefit for electromechanical joining systems. Then you go beyond that. Not only does it provide more control, but then you have less waste as a result of that. So great insights across the board, how you tie in with sustainability. Jim, you've been batting cleanup this whole time, so you get to answer this last one. Where's the best spot to connect with Kistler? Where can we find you here at the conference and afterwards as well?
Yeah, I mean, certainly come on over to our booth. Sorry, I can't remember the numbers. It's 1826, I believe. But is that right? So yes, please come over to our booth. We have all these different technical solutions at our booth, and you can come and see us there. And we can show and explain how that technology can be used for the different processes, whether it's medical molding, whether it's joining systems, and also for the in-process monitoring applications.
And then after the show, LinkedIn and online, where are the spots to find you there?
Come to Kistler.com. That's our main website. You will find all the information there. And we also have a presence then on LinkedIn where you can find additional information.
Excellent. Well, Petr, Jim, Hiro, thank you so much for jumping on. Automate Live will be coming right back to you real soon.